Hi, we have this big integral on the board, 5 cosine 23x plus 5 cosine 7x over 2 sine 23x plus 2 sine 7x. To start with, we can factor a 5 out of the numerator and a 2 out of the denominator. So we're going to have a 5/2 out front when we do that. So the problem we have is we have two different angles in the numerator and the denominator, and also that they're not, if the angle was 2, we could use an angle reduction formula, but that's not going to work very well for 23 or 7. So we have these two common identities for different angles, and you'll notice that what's in parentheses here looks a lot like the numerator, and what's in parentheses here looks a lot like what's in the denominator. And then we can actually multiply a 2 on both sides to create just a slight variation on this formula, right? And that cancels out there. So then what we'd like to do is, if we could take this and transform it into this form, this could be easier to work with. And the other thing that's interesting with this problem is it's a pretty common problem to go the other way and use this formula to break it up this way. If there wasn't a fraction, if it was just like the top piece of the bottom piece, you'd go in this direction, and then you'd split into two simple separate integrals, and that'd be pretty easy to solve. So now, in order for us to use this formula and have this match up, we're saying a plus b is going to be 23x, and a minus b is going to be 7x. So we can just do some simple algebra to solve that. So if we say that a plus b equals 23x, and then a minus b equals 7x, let's just add these equations together, and we'll have 2a equals 30x, so a equals 15x. Next we can do something similar. We just subtract both equations, so then b equals 8x. All we need to do now is take our a and bring it back into here, and bring our b and plug it in here. So rewriting the integral using the formula from the previous board, we have this configuration. And what you notice we did is we took where these were addition, now it's multiplication, and that's going to allow us to do a lot of cancellation. So we can cancel a cosine 8x, we can cancel our 2. So you'll notice this is actually just cotangent of 15x, but what we'll do, let's just do this out with a u substitution so it's clear. So we'll say our u is going to be sine 15x, and then our du is going to be 15 cosine 15x. We'll create a 15 in the numerator, and then we'll just multiply by 1/15 outside. But then 5 is going to cancel with 15, and we have a 3. So then let's rewrite this whole thing. We're going to have 1/6, and the integral of this piece up here is just our du. So we're going to have du over u. Now we can integrate. We're going to have 1/6 ln absolute value of u plus c. But we know what our u is, right? It's just this sine of 15x. So then our final answer is just going to be 1/6 ln absolute value sine 15x plus c. And that's it.